Hi there everyone, my name's Lucian Wishick. I'm on the VB C# language design team and I'm going to be talking today about 3 essential tips for async. I've been working on async myself for the past 3 years of my career, and over the past year especially I've been watching how people have been learning async and using it. What I wanted to do in this talk was to extract out the most important bits of this knowledge that I found, to figure out 3 essential tips that will make you a better async programmer. These, just in a nutshell, these are the 3 tips. Number 1, async void is for top-level event handlers only. Number 2, be very careful to understand what is CPU-bound code and what is I/O-bound code. Number 3, learn how to use task completion source to turn events into tasks. We'll be diving into all of those in a lot more detail and seeing lots of code for it. But before we do that, I wanted to step back for a minute and understand how async actually works, because I believe that if you understand the control flow of an async method, then you can ignore the rest of the tips because you'll be able to figure them out yourself. Well, let's start. Here, I've put up this code and it's got the message pump and it's got a very simple async button one-click event handler. What happens is that when the user clicks a button, the UI message pump goes around and it invokes the event handler. And because the first thing the event handler did was call load settings async, it goes in here, load settings async. And the next thing it does is call download async. And when it does that, it has an await statement. So the task that was returned from download async gets saved on the heap. I've put that with a little star here. And control flow returns straight back to where it was. Let's state this very clear because that's the most important thing about async control flow. At the first await in a method, control flow returns back to the caller. Well, here we are in the caller inside async void button click. It called load settings async. That was a task returning method. So we have a task object here and then we await it. What happens when you come to the first await in an async method? Well, you return to your caller. In this case, we're returning to the message pump. This message pump really is the single most important key to understanding how async works. Well, control returns to the message pump, and that means that the program is now responsive to further UI interactions. If a button click happens, we can respond to it straight away. Here, we just saw it responding to one. Later on, let's say, maybe 2 seconds later, the answer comes back from the network. When that happens, this is going to be a bit complicated. Let's watch that again. When the answer comes back from the network, the task that represented our waiting for a download to happen on the network gets marked as completed, and therefore it is available for the message pump to resume where it left off. It has this hyperspace jump back to where it left off, to just after this await statement. Well, it's now going to be able to finish the method it was in, and this is complicated again, so we'll step through it again. When it finishes an async task returning method, then the task that it had returned gets marked as completed, ready for the message pump to handle when the message pump is free to handle more messages. So the message loop, the message pump goes around, it comes to this completed task, and it jumps via this hyperspace straight back to the await that it left off of, or just after the await. Once again, it can finish the code it was doing and return back to the message pump. Okay, so that was the underlying async mechanism. I understand that it's a bit complicated, and even if you didn't follow all of this, that's fine. You can rewatch it again, or you can say, let's put this underlying mechanism to one side and let's understand what it implies. What are the 3 practical ramifications of this underlying mechanism? The important thing to always keep in our heads is that where is the thread of control? We didn't spawn multiple threads in that code just because we used async and await. It did not create multiple threads. It still used the same thread of control. And what we're going to see in the next 3 parts of this talk is tip number 1, async void is only for top-level event handlers. Tip number 2, figure out the difference between CPU-bound code and I/O-bound code. Tip number 3, we'll learn how and why to use task completion source. Thank you.